Hello everyone, welcome back. Today we are going to be solving the JEE Advanced 2024 paper, and I know it's an easy paper, but let's see. I would be solving a few questions and I'll upload more if this video is liked enough. And let's start with it. So the first question is about, there's a limit given us, limit given to us, and we have this condition. So yeah, it's a differential equation question. All the questions are pretty straightforward in this question paper. Even the probability one is pretty straightforward. So let's start now. So the key to solving this question is just to keep in mind that x is constant with respect to t. So we can apply L'Hospital and we would get 10 t power 9 fx minus x power 10 f dash t upon 9 t power 8. And yeah, you can just apply the limit, and so 10 x power 9 fx minus x power 10 f dash x is equal to 9 x power 8, and x is greater than 0, so x is not equal to 0, so we can just remove all these extra powers of x, right? So this should give us 10xy minus x square dy by dx is equal to 9. This would be our differential equation, and yeah, it's very easy. So let me just go on and simplify this in a way. And dividing by x square, I should get this. And yeah, I think this is pretty much solvable, so I should leave it here. Like, you know how to do the calculation for the integrating factor. This is a simple linear equation, uh, linear differential equation, and the answer would come out to be B for this one. Okay, next one is a probability one. So a student appears for a quiz consisting of only true false type questions and answers all the questions. The student knows the answers of some questions and guesses the answers for the remaining questions. So whenever you get these questions, you should first you know uh, make a chart, or something that looks like a mind map. Like, a student knows the answers of some question and guesses the answers. So like, if there's a question, then either he knows the answer or guesses, right? And whenever the student knows the answer of a question, he gives the correct answer. So when he knows the answer, the probability of being correct is 1, right? And okay, so we have not been given anything about how much probability it is when he guesses. So assume that the probability of the student giving the correct answer for a question, given that he has guessed it, so probability of correct when he has guessed it is half. So guess is correct or wrong. So these are all our cases, so this would just be half, right? And this would also be half. So also assume the probability of the answer for a question being guessed, given that the student's answer is correct, is 1 by 6. So probability of question being guessed given that the student's answer is correct is 1 by 6, which can be written in this form. So if we look at this, so let's take, so we want to find the probability that a student knows the answer of a randomly chosen question. So we need to find the probability x of this part. So this would be 1 minus x, right? The probability of him knowing is x, and the probability of him guessing the question is 1 minus x. So this would be our case. So to find probability of guessing and also being correct at the same time, so and case would translate to be 1 minus x times half, right? And the probability of being correct would be x times 1 plus 1 minus x times half, right? So and this is given to be 1 by 6. So if I calculate, this should be 1 minus x by 2 upon 1 minus x by 2 plus let's write this as 2x by 2. So 1 minus x upon 1 plus x is equal to 1 by 6. So yeah, I think I have solved correctly. X should be 5 by 7. Yeah, so this should be the answer for this question. I think my explanation in this one was pretty good. So this was very easy to understand. Okay, let's move on to the next question. And also that it's been just 6 minutes into the video and we have solved 2 questions. This one is also very easy. The key is to take sin x and cos x out of this and separately add them up, or should I even do this? This one is a very easy one. I don't know. Let's just leave this one. It's very easy. You can just I'm telling you what to do. Just take sin x, just club the sin x terms and cos x terms together and use this thing. And you also have, so you would get something with the need of, I think, yeah. So this would be 12x by 2 minus 11x by 2, and this would be x by 2, and x by 2 would be from pi by 4 to pi by 2. So you would be able to say that x by 2 belongs to 0 to pi by 2, and from here you can find the other values, right? So this is very easy. Okay, so let's move on to a coordinate question. So this should be interesting. So we have the ellipse x squared by 9 plus y squared by 4 is equal to 1. So making a graph of this, and SPQ is in the first quadrant such that it is outside. So clearly we can say that S1 is greater than 0. This is what they have written here. So let's take this to be PQ. Two tangents are drawn from S to the ellipse, of which one meets the ellipse at one end of the minor axis. So this is the minor axis. It can't meet this end because that would make a chord through the ellipse. So yeah, so if it meets the tangent, it's very logical to say that this would just be a horizontal line, right? Because yeah, it's gonna touch it. So like half of the options are eliminated straightforward because the y value of s is going to be 2. So q is just simply 2. And yeah, these c and d options are completely useless reading the first 2 lines of the question. So yeah, I mean, paper was way too easy to be a JEE advanced paper, whatever. And the other one meets the ellipse at a point T in the fourth quadrant. So yeah, somewhere here. So let's say this is T, and R is the vertex of the ellipse with the positive x coordinate. So this is R. O is the center of the ellipse, which is also the origin, and we have been given that the area of the triangle ORT is 3 by 2. So why not just like 0 0 3 0, and this is let's take this point as 3 cos theta comma 2 sin theta. That would be the best way to solve this. And actually there is the shortest method to do this question is to first use this thing, right? So people might be tempted to first write the equation of the tangent, but first you should go for this. Area of the triangle is this, because the area of the triangle is just pretty easy to solve, and it would give you a conclusive thing out of it. So this is given to be 3 by 2. Now note that t is in the fourth quadrant, right? So yeah, you would clearly be able to say that sine theta would be less than 0 and cos theta would be greater than 0. So you don't even need to check the trigonometric stuff in that. So clearly this is 6 sine theta and this is 3. So yeah, sine theta is half, or to be precise, minus half, because yeah, area uses mod as well, right? So the determinant comes with the mod, so sine theta is minus half and cos theta would be plus root 3 by 2, because yeah, I just said it's in the fourth quadrant. So yeah, we have this result, and now the question is just almost over. So we can just say that let's write the equation of the tangent by t is equal to 0. So I know the points would be 3 root 3 by 2 comma minus 1, right? So, or to be precise, we can write this, in fact, it would be better in this way: x cos theta by a plus y sin theta by b is equal to 1. And once you do that, you can just put in y is equal to 2 and x is equal to p, and you would get p is equal to 3 root 3. So yeah, I don't need to do each and everything, right? And this is the last question. I like this question kind of, because I have solved way too many complex number questions, and this one I have done like 3-4 times. So let's do it again. So S is the set of all numbers that can be represented as a plus b root 2 such that a and b are integers, and T1 is this set and T2 is this set. So the main thing in this question is just that root 2 is equal to 1.44, right? So they just want to imply that this is a number which is between 0 and 1, and this one is greater than 1. So this is the main thing about selecting this type of set. There is no binomial theorem, or probably somewhere, right? Yeah, in the first question you have a little bit of binomial theorem. So the first option talks about Z union T1 union T2 is a subset of S, no, belongs to S. So so integers, can integers be in S? Yes, they can. For b is equal to 0, a belongs to Z is literally Z. So yes, Z can belong to S. What about T1? So T1 can be minus 1 plus root 2 power n, such that n is an integer, and basically you can clearly say that all the root 2 terms, that would be you can write this as a binomial expansion, and the odd terms which would be root 2 power r, or 2r minus 1, let's say, these would be left with root 2, and all these terms would make b root 2, and the other terms would make a. So these all can also be represented as S and also T2. So the first one is a very straightforward part, that can you represent them as a plus b root 2? Yes, you can. So a is clearly correct. Okay, what about b? So it's talking about T1 intersection 0 to 1 by 2024 does not have any elements. That's what it's saying. So T1 is, if you look at root 2 minus 1, it's going to be something like 0.44 power n, and n is any integer. Now the option is claiming that there is no element between 0 to 1 by 2024, but if you go till like n tending infinity, you would start to reach 0, and there is going to be infinite elements between these. So this is completely wrong, right? So this should not be phi actually. And about t2, you would have 1.44 plus 1 something power n, so this would be 2.44 power n, and this is clearly a greater than 1 number. And if you raise this to infinity, yes, you would have a lot of elements between 2024 to infinity, so it's not equal to phi, and this is a correct statement, so this should be correct. And for the next one, we would have, for any given a and b belongs to integers, cos of this plus iota sine of this belongs to z. So clearly this is e power iota pi a plus b root 2. I can write this as e power iota pi a times e power iota pi b root 2. So for a, as a belongs to z, this part is just going to be oscillating between this and this, so this would just go, so this for 1 it would be here, sorry, here, for 2 it would be here, here, then 3, 4, and it would go on. So this I can just write it as plus minus e power iota pi b root 2. So it's very obvious that you would not have it belonging to integer, and it would only and only be integer for b is equal to 0, because e power iota pi root 2 does not make sense. It just does not. I mean, there is no significant explanation about it, but it's pretty straightforward that it is not going to be. I mean, you can prove and do a lot of scientific stuff, but it's clearly, it's pretty obvious. So yeah, I think that's the 5 questions that I'm going to be solving today. Other ones are kind of boring. So yeah, the whole paper was kind of boring. Like this one, this question was like way too easy for 11th grade students. This one also I have done a lot of times. Um, it's also simple. Yeah, I think that's enough. I think I'll just sign off. That's enough for today. Yeah, I hope you liked the video, and yeah, keep like for more questions.